Again, nodal analysis. If this is the figure, we need to set ground. Then we need to set variables to that nodes like V1, V2, and V3. Then we need to set specific currents for each resistors. Then we need to analyze using Kirchhoff voltage law. Summation of current in will be equal to the summation of current out. This is very important. That means if we are analyzing at node 1, so we need to identify the possible currents that leave and enter the node. So there will be no incoming, but there are outgoing. So that means it will be 0 equal to current 1 plus current 2 plus current 3. So this will be the equation 1. So we have to follow the steps for you to solve the nodal analysis. This is where the equation 1 will come from. So you have to convert them in terms of voltages and resistors or using the Ohm's law. We have now 0 equal to, so the initial, which is V1, then the final, you have to subtract the voltages from that current. So that means if that is current 1, we have the initial voltage of V1 since it enters the positive in 30 volts. So that will be V1 minus 30 divided by R1. Okay, R1, since R1 is 20, I will put it here that is 20. Then, for the current 2, that will be V1, the initial, minus the final of V3 divided by resistor 50 ohm. Then, if that is current 3, that will also be V1 minus V2 divided by 90. Okay? So, that will be the equation. Then, you have to, okay, so ganyan yung format niya. Next is that you use so 0 is equal to 45, 18, then plus 10 V1 minus V2. So this will be 0 equal to 45 V1 minus 1350 plus 18 V1 minus 18 V3 plus 10 V1 minus 10 V2. So, equating it, that is 1350 equal to 73 V1 minus 10 V2 minus 18 V3. So, this is equation 1. Okay. Next, node V2. So, we have incoming plus is equal to the outgoing. So, outgoing here, that means this portion, I will note na lang here that V3 is equal to V2. Kasi walang resistor in between them. So, it will be the same node. So, ito, pag this will be 28 V2. Okay. Next, at node V2, here. So, remember, V2 and V3 are equal. So, that means I2 plus I3 equal to I4 plus I5 equal to summation of outgoing. Then, incoming will be I2 plus I3 equal to I5 plus I4. Okay? Then, since V2 ang ginamit natin dito, I have to use V2 also here. Following, taking note that V2 is equal to V3. Okay, so that means if I convert these currents with respect to voltages, that will be V1 minus V2 divided by current 2 is 50 ohms. Then, next will be V1 minus V2 divided by 90 ohms equal to, so initial is V2 minus 0 over 30 tapos plus V2 minus 0 over 100. So that will be the equation. Then again, the next step is to make it in single line only. So that means it will be 18 times V1 minus V2 plus 10 V1 minus V2. Transposing yung kabilang side, so that will be minus 30 V2 minus 9 V2 equal to 0. Simplifying that, 28 V1 minus 67 V2 equal to 0. So, solving by elimination method, since equation 2 unknowns, so we can use the elimination method. This is the equation 2. Elimination using 1 and 2. So that will be eliminating V2, that is multiply this by 67 and ito times 28. So that will be 90 for 50, then equal to for 891 V1 negative, then plus 1876 V2, then dito is 0 equal to 784 V1 minus 1876 V2. So that will be negative 90 for 50 equal to negative 4107 V1 and ito cancel. Therefore, we will have now the value of V1 is equal to negative 90 for 50 divided by negative 4107. So that is V1 equal to 22.0234 volts. Okay? Is it correct? 22 something. Tama. If you will look at the circuit, so here at this node, there will be 22 volts. So upon computation, there is 22.0234 volts across V1. So how to be determined for V2? Substitution method. To follow that V1 to equation 1, we will have the value of V2. So that means 1350 equal to 73 times 22.0234 minus 28 V2. You will have the value V2 is equal to 9. What's the V2? V2 is 9.2038. So it matches the voltage or the solution on the other side. So we now have V1 equal to 22.0234 while V2 is equal to 9.2034. So we can now look for the values for I1. So dapat it will match dun sa solution natin before. So that means I1 is equal to, again, that will be V1 minus 30 divided by 20. As you can see, the direction of the current is going to the left. That will be, since that is 22.0234 minus 30 will arrive to the negative. So that means it will go on the other side. Will face the different direction. So that means I1 should be negative 398.83, 83 something, depende kasi ini-lesson ko na siya into 4 decimal places, so nawala na yung iba. So that will be negative 398.83 milliampere indicating negative sign. So the flow of the current should be going to the left, which is correct when we look for this 399 milliamp going to the right. But if you're going to state it here, it will be negative 398.83 milliamp going to the left, indicating that during the actual, it will turn into the right. It will go on the other side. Because we have different way of assignment. Kasi siya ay nodal analysis, where all the current should flow going to the ground. Then if that will be I2, no, so that will be I2 equal to B1 minus B2 divided by 50. That means it will have 22.0234 minus 9.2034 divided by 50. It will have a positive flow. So tama na, it should be going down. So that is 256.1 milliamp. Pero again, during the solution, you should follow the 4 decimal places. So as much as possible, you have to store the original value to eliminate any undesired reduction of the decimal places. So I3 is unknown. So that means same then. For this time, this will be I3 and the resistor is across I3 is 90. So that will be 22 minus 9 divided by 90. That will be 142.444 milliamp. Then I4 is unknown. So I4 is equal to V2 over 100. So if B2 is 9.2034 divided by 100. So I4 is 92.034 milliamp. And I5 equals V2 divided by 30. So that will be 306.78 milliamp. Okay. So checking 92, 307, 142, 256. So all of them are correct. Using nodal analysis, it is faster since we tend to have lesser number of unknowns, unlike mesh and KVL, KCL, where you have to have multiple variables.